What's happening, y'all? Let's move on to Chapter 9 here. Let me zoom in a little bit, right, with my advanced technology here. There we go. So Math Patterns, Section 9.1. Very exciting. New chapter, a new start, a new everything. So we're going to look at a sequence of numbers. 5, 8, 11, 14. So this is a pattern that continues on. It's a math pattern. It's an arrangement of numbers. We're going to come up with a couple of different, we're going to talk about a couple of different types of formulas today. So formulas. The first one is going to be explicit, and the second one recursive. Okay, so there's two different kinds of formulas we're going to use to basically describe the same thing. And sometimes one's easier than the other, and sometimes you can do one and not the other. So it really depends. So explicit and recursive. C-U-R, it's cursive like writing, I guess. Recursive, but has nothing to do with the writing. Okay, so for this formula, the explicit formula, or sorry, for this pattern, the explicit formula is pretty easy. Okay, let me first note how we write this. I'm going to start with a sub n. It's an a with a little n. And that's kind of like the f of x notation, except a with a little n instead of the x in parentheses. Okay, well, what does it equal? Let me see. The first thing you're going to look at here is every term goes up by 3. Okay, so here I'm going to put 3n, because if I increase n by 1, you get 3 more. Okay, so when n is 1, it's that term. When n is 2, it's that term, and so on and so forth. So I'm going to start with 3n here. 3 times 1, this doesn't work though, right? We're not finished. 3 times 1 is 5. I'm sorry, is 3, and I want 5. 3 times 2 is 6, but I want 8. 3 times 3 is 9, but I want 11. 3 times 4 is 12, and I want 14. Well, if you think about those numbers, 3, 6, 9, 12, they're all 2 less than the value here. So I need to add 2 to my formula to make that work. Okay? Now if I put in 2 here to get the 8, 3 times 2 is 6, plus 2 gives me 8. So now I can use this formula to find the millionth term. If you put in a million for n, 3 times a million is 3 million, plus 2, 3 million and 2. So this is an explicit formula. It allows me to directly find any term. We also have recursive. And we'll need more than a line to do this. So for recursive, I'm going to have a couple notes here as well. You need an initial value. And second, you need a formula relating to the previous term. Okay, so let me start first by, let me see. First I'm going to say, well, a sub n, which we used up here, it means the current term. Okay, we're going to see things like this. A sub n minus 1. That means the term before. And we could even go further. M minus 2. That would be the term 2 before. Okay, and you could go so on and so forth to a minus 10. 10 terms before this one. So that's kind of going backwards. Let me look up at the top. So this is the third term. So if I was saying, well, this is a sub n, and the term before it would be the 8. Okay, so this is just going backwards in the sequence. This is the mathematical way that we write it. If I want to look back, the term before, the term 2 before, and so on. So let's look at that same pattern, okay? And what I want to do is I want to say what's happening here in terms of the term before it. Well, every term is 3 more than the term before it. So let me write that. Let me write that first. Let me change my colors. I haven't changed colors yet. Every term is 3 more than the term before it. I have to kind of squeeze that in there. I apologize for that. Okay, well, every term, that will be the current term, so let's call that a sub n. Is means equals. Is always means equals when it's by itself. 3 more than. And the term before it, that's a sub n minus 1. So I'm going to make that a little more compact. Okay, so this is the mathematical way to say how each term relates to the previous term. Each term is 3 more than the term before it. Okay, that's kind of cool. So you're just kind of substituting those words in for the a sub n and the a sub n minus 1. Now, we kind of went backwards here, right? In the recursive definition, we need somewhere to start an initial value and then a formula relating to the previous term. We have the formula, and I just need the initial value. The first value was 5. So I'd also say a1 is 5. So every term is 3 more than the term before it, and the first term is 5. And that is a recursive formula. Go ahead and think of stuff for your left-hand side.